Genetec Security Center 5.2 Prerequisite Training, Module 1, Network and IT Basics. In this training module, we'll be looking at a networking review, some database basics, several Windows utilities, and some storage basics. Let's begin with the networking review. What is an IP address? An IP version 4 address contains 32 bits of information divided into 4 octets in standard human-readable notation. For example, the value 192.168.100.145 is a valid IPv4 address. Notice that the information is broken into 4 octets, each separated by a decimal point. On this network, the first 3 octets don't change, so we say that we have a 24-bit subnet mask. This can be expressed as 255.255.255.0 or 192.168.100.0/24. Every device with a network card, like a server, a workstation, an IP camera, an IP door controller, must have a valid IP address assigned to its network interface. What are address classes? Address classes are ways to identify different types of IP addresses. Each class has a specific range of addresses associated to it. Class A, Class B, and Class C addresses are all what we refer to as Unicast address, wherein an individual address is assigned to an individual network card. Class D also has its own range. However, these addresses are reserved for multicast transmissions. And there are some other special kinds of addresses, like 169.254.x.y, reserved for self-assigned IP addresses, or 255.255.255.255, which is known as the broadcast address. What's important for us to remember is that Unicast IP addresses can fall into Class A, Class B, or Class C. They're encompassed by the range 1.0.0.1 all the way up to 223.254.254.254 and everything in between. These are addresses that are assigned to workstations, servers, IP cameras, door controllers, or any other device with a network card. The other range we need to keep in mind are Class D. These are reserved for multicast transmissions. And Class D represents the range of IP addresses from 224.0.0.1 up to 239.254.254.254. What is a port? Well, we can consider an IP address a bit like a physical street address. A hotel might have a single physical street address, but behind its street address, there are many possible rooms. We could identify a hotel as being found at 123 Main Street. But if I want to visit a guest in the hotel, I'll need to know the hotel street address and the guest's room number. Room 302 is where Mr. Lee is staying. Room 417 is where Mrs. Perez is staying. Room 551 is where Mr. Thomas is staying, etc. So to visit a guest in the hotel, I would need to know the physical street address and the room number. Well, IP addresses and ports work in a very similar way. Every network card has one IP address assigned to it. But behind that IP address, there may be many possible servers or services or applications listening. For example, if we take the IP address 192.168.100.10 and we say that this is the IP address that's been assigned to our server, well, behind port number 21, we may find an FTP server. Behind port 23, a telnet server. Behind port 80, a web server, etc. How to set our own static IP addresses. While DHCP addresses assigned to workstations are supported in Security Center 5.2, We often find that setting static IP addresses is preferable for the client workstations. To set a static IP address, there are slightly different procedures depending on your operating system. In Windows XP, select the Start menu, Network Connections, right-click on the wired adapter or the network card, and select Properties. In Windows 7, we can click the Start menu, go to the Control panel, open the Network and Sharing Center, and select Change Adapter Settings. From there, right-click on the wired adapter or the network card and select Properties. Once your network card's Properties window is open, whether it's XP or Windows 7, we would select TCP/IP and click Properties. A dialog box will then open, allowing you to assign your own static IP address. At a minimum, 2 values will be required: the IP address and the subnet mask. Optionally, a gateway value can be entered, as well as DNS server IP addresses. Once an IP address has been set for a given workstation, it's always a good idea to test the configuration by trying to ping a host. Typically, we would try to ping the Genetec server. To ping a host, we begin by opening a command prompt. In Windows XP, this can be done by clicking the Start menu, selecting Run, and typing the command cmd, Enter. In Windows 7, a command prompt can be opened by clicking the Start menu and typing cmd in the search box, and Enter. Once a command prompt is open, type the command ping, P-I-N-G, space, your server's hostname or IP address, and hit the Enter key. You should see replies from the server. Firewalls may block certain types of traffic needed by Security Center. However, network ports can be modified in the server admin and in the config tool. Security Center is usually installed on an isolated network, reducing the need for firewalls. To disable the built-in Windows firewall, click Start, choose Run, and type the command firewall.cpl. Then click Disable. Most corporate networks are also protected by hardware firewalls. To open ports on the corporate hardware firewall, you may need to make a request with the corporate IT department. There are many network ports used by a Security Center system. A full list of all ports can be found in the Security Center 5.2 Administrator's Guide. Let's look at the difference between TCP and UDP. TCP is what we refer to as a connection-oriented protocol. UDP is a connection-less protocol. Sending data using TCP is reliable, the data is ordered, yet it's heavier on a network. Sending data using the UDP protocol is unreliable, the data is not ordered, yet it is much lighter on a network. Sending data using TCP, or Transmission Control Protocol, involves a certain error checking mechanism. When data is sent from a source to a destination, like for example an IP camera to a workstation, in the world of TCP, every packet that's sent must be acknowledged by the destination, acknowledging that that packet was in fact received. Therefore, if packets are lost on the network, retransmissions will begin such that the destination will have received every packet that was sent by the source. In this animation, we can see that TCP packet 3 was lost on the network. It is therefore resent such that all of the packets were ultimately received by the destination. Errors are recognized and corrected. However, TCP is heavyweight and slower on a network. A UDP transmission, however, involves no error checking mechanism. Sending data from a source like an IP camera to a destination like a workstation using UDP looks something like this. In this animation, we can see that if a given video packet is lost, no retransmit is sent, and the transmission continues with subsequent packets. UDP is much more lightweight and faster than TCP. However, there's no guarantee that every packet will reach its destination. Multicast is a type of transmission built using UDP packets. A multicast transmission involves a single transmission, yet multiple recipients. The source could be an IP camera, found at 192.168.100.25. The destination might be 3 specific workstations, yet not all computers on the network. So multicast is generated by sending the video packets to a special destination address, not the Unicast address belonging to any one of the individual workstations, but rather a Class D address like 224.16.17.10. If an IP camera sends its video packets to this destination, it will allow several, but not necessarily all, computers on the network to receive it. Multicast is an efficient way for several workstations to view the same single video transmission from an individual camera, without flooding the network by broadcasting the video everywhere. RTSP and RTP are 2 other protocols used in a security center system. RTSP, or Real-Time Streaming Protocol, is the communication protocol used between a client workstation and a server. And it handles requests for video and audio streaming sessions. The RTSP protocol includes basic multimedia commands like play, pause, and record. RTP, or Real-Time Transport Protocol, is what's used to handle the transmission of video and audio over UDP. RTP contains timestamp and packet sequence information. It allows for packet loss detection and packet ordering. In other words, RTSP is really the protocol used for command and control of our video and audio streams, while RTP is the protocol used to move the actual video or audio packets. What determines whether a transmission will be managed as a unicast transmission in a one-to-one relationship, a broadcast transmission in a one-to-all relationship, or a multicast transmission, a one-to-many relationship? To perform a unicast transmission, the critical factor is the destination IP address included in each one of the packets leaving the source. So, if an IP camera, for example, sends packets to destination IP 192.168.100.102, when the packets arrive at the switch will manage this as a unicast address, one single source, one single destination. Let's change the destination IP address used in the packets being sent by the camera. So, same scenario, except that this time the camera is sending its video packets to destination IP 255.255.255.255. When those packets arrive at the switch will in turn broadcast them or repeat them on every port, thereby forwarding these video packets to everybody on the network, whether they want it or not. Lastly, multicast transmissions reflect a one-to-many relationship while avoiding a broadcast scenario. And to achieve a multicast transmission, once again, the critical factor is the destination IP address included in each one of the individual video packets. So this time, the camera can send video to a special IP address, a Class D address, 224.16.17.15. And when those packets arrive at the switch will then create what's known as a multicast host group. To receive the video stream, servers and clients will send a request to join the group, and they will then receive the multicast video stream. In this way, two specific destinations will receive the video packets, yet not everybody on the network, as we will not broadcast or flood the network with video packets. What happens if we try to send a multicast transmission without the proper switching equipment? A hub, for example, has no idea how to manage multicast. Any multicast packets sent to a hub will in fact be broadcast or repeated on every single port, usually flooding the network. What if we use a simple switch that doesn't support multicast? When the camera sends multicast packets to a Class D address, a multicast address like 224.16.17.15, those packets arrive at the switch, but the switch doesn't know how to manage multicast, and simple switches will in general broadcast the multicast packets to every member on the network, thereby flooding the network. It's difficult to see the advantage or the efficiency associated with multicast transmission in the previous illustrations, as they were simplified to show only one switch. However, most corporate networks contain multiple switches and possibly routers. And when we look at a multiple switch environment, we can see how multicast transmissions can add bandwidth efficiency to a given security center system. Take, for example, the case where a single camera needs to be seen in 4 possible destinations. Imagine if we've got a security monitor connected to a decoder mounted on the wall of our operations room. Perhaps we've got a technician working with a laptop, doing troubleshooting on a given camera. We've got a security operator monitoring all of our cameras on a dual-screen workstation. And we've got an archiver server who needs to receive the video packets for recording purposes. This one camera needs to be seen in 4 different places. This can be achieved using multiple Unicast transmissions. However, 4 individual Unicast transmissions would have to be sent. One to the decoder with the security monitor on the wall of our operations room, one to the technician working on the laptop, one transmission to the workstation, and one transmission to the server. A total of 4 transmissions. The same thing can be achieved using a single multicast transmission, which we can see in this illustration with the blue lines. The camera can send one multicast transmission, which will be received by the decoder, the laptop, the workstation, and the server, thereby saving 4 times as much bandwidth on the first link from switch 1 to switch 2, and 3 times the bandwidth on the second link from switch 2 to switch 3. Multicast is based on the Internet Group Management Protocol, or IGMP. There are 2 IGMP features that need to be supported for proper multicast management to work, what's known as IGMP snooping and IGMP querying. IGMP snooping is a layer 2 role, and it allows the creation of multicast host groups such that packets are forwarded to ports where hosts have requested membership. IGMP querying is a layer 3 role, and is responsible for sending query messages to all hosts asking if they want to receive multicast traffic. Every switch is different, and the management interface displayed by each particular model of switch might present many multicast configurable parameters or very few multicast configurable parameters. On this page, we're looking at 2 different switch configuration pages, both from Dell switches. One offers us a variety of multicast configurations, and the other simply offers multicast to be enabled or disabled. Command line IP tools. There are many basic command line IP tools included with your Windows operating system that are often used by Genetec's tech support department when troubleshooting video issues. Commands like the ping command, useful to test network connectivity with a host, the NSLOOKUP command to test name resolution, the ipconfig command to list your IP configuration, subnet, default gateway, DNS, and MAC information. The traceroute command determines a network path to a given destination. The pathping command, similar to traceroute, but calculates reliability statistics for each hop. And the netstat command that lists the protocol, address, ports, and statuses of all connections. Ultimately, Genetec's tech support department will often turn to a packet sniffer as the final troubleshooting tool for network video problems. A packet sniffer, or protocol analyzer, is software that captures and analyzes all packets passing through a given network card. It's used to diagnose network problems and determine method of delivery of packets between multiple points on the network. The screenshot we're looking at is an image of Wireshark, a freeware packet sniffer, as we're troubleshooting a network on which we suspect multicast might not be supported. The simple test using the Wireshark packet sniffer involves setting up two workstations. One workstation displays a camera streaming multicast, and the other workstation doesn't. Rather, it simply runs a Wireshark capture. The Wireshark capture shows us that even though video was not requested by the second workstation, it is receiving many UDP packets whose destination IP is a Class D multicast address. We could conclude from this packet capture that this network does not support multicast. Multicast packets are being broadcast to everyone. Database basics. What is a database? A database is a collection of data organized for rapid search and retrieval. The data is saved in tables, much like an Excel spreadsheet. Tables are linked and grouped together to form the database structure. A database instance includes the tables, the database structure, stored procedures, memory, and anything else that might be needed to use the database. Some examples of databases used by a security center system. The directory role manages a system configuration database. The archiver role manages a video event database. The access manager manages an access control event database. Various database engines. The server software used to manage a database is called a database engine. There are various possible database engines available, for example, Microsoft's SQL Server, Oracle, PostgreSQL, MySQL, Informix. Genetec servers use a Microsoft SQL Server as their database engine. Which versions of SQL can be used on a Genetec server? Security Center 5.2 supports Microsoft SQL Server 2008 R2, Express, Standard, or Enterprise editions, or Microsoft SQL Server 2012, Express, Standard, or Enterprise editions. During the installation of a Genetec server, the installer offers to install a free version of SQL, known as SQL 2008 R2 Express. Some database considerations. The Express version of SQL Server is free, and as such has certain limitations associated to it. For example, an SQL Express server supports only one processor, will use only up to 1 gig of memory, and does not allow the database to exceed 10 gigabytes in size for SQL Express 2008. As an idea of how large a database will grow in a Genetec system, An archiver's database can reach 4 gigs on a 120 camera system with 60 days of storage. Reasons why some people would prefer to upgrade to a commercial SQL server, either standard or enterprise, are that the commercial versions of SQL Server support not 1 but up to 32 processors, not 1 gig but up to 64 gigs of memory, and support a maximum database size of over 1 million terabytes. Lastly, Windows clustering is supported in SQL Standard and Enterprise and not supported in SQL Express. Managing Windows. Applications and services. Security Center software includes both applications and services. Applications are usually installed on workstations, while services are usually installed on servers. Applications must be explicitly launched. Applications present a graphical user interface, and users interact with applications using their mouse or keyboard. Services, on the other hand, launch automatically, and services do not offer any graphical user interface. Processes. Both applications and services run processes. A computer program, either application or service, is really just a passive collection of instructions. A process is the actual execution of those instructions. Several processes may be associated with the same program. Some examples of common processes in Windows. Microsoft Word runs the process winword.exe. iTunes runs the processes itunes.exe and ituneshelper.exe. Internet Explorer runs the process iexplore.exe. The Windows Task Manager. The Windows Task Manager is a task manager or system monitor application included with the Windows family of operating systems. It provides information about our computer's performance, the running applications, services, and processes, CPU usage and memory information, network activity, statistics, and logged-in users. The Windows Task Manager is often used as one of the first troubleshooting tools when diagnosing a software problem. Using the Task Manager. The Windows Task Manager can be launched in 2 ways: by pressing the keys Ctrl, Alt, Delete at the same time and clicking Task Manager, or by right-clicking on the Windows taskbar and selecting Task Manager. In this image, we can see that the Task Manager has been opened on a workstation that's running the security desk. Under the list of all processes that are active on this workstation, we find a process called securitydesk.exe. Storage basics. The importance of storage. A security center system managing video will generate enormous amounts of data, video streams, that need to be stored or recorded. A security center system managing many doors and inputs will need very fast access to a hard drive for intense bursts of read and write activity. Both disk space and disk performance are 2 potential bottlenecks to any security center system. The general rule of thumb: the faster the disk throughput in terms of reads and writes, the better the system performance. Storage device technologies. There are many different technologies used for the storage devices themselves. Hard disk drives, solid-state disk drives, USB storage, flash storage, optical disk drives, storage arrays, storage area networks, and network-attached storage. Hard disk drives and solid-state disk drives are typically used by security center workstations. Storage arrays, or RAIDs, and storage area networks, or network-attached storage, are typically used by security center servers. These days, more and more cameras are introducing flash storage on the camera itself. Regardless of the storage device technology, the storage device still needs to be attached to the host or the computer that will be using it. There are different storage attachment technologies to connect a storage device with its host. ATA, IDE, SATA, USB, Fiber Channel, SCSI, and iSCSI are different examples of storage attachment technologies. We typically find ATA, IDE, SATA, and USB attachments used by Security Center workstations. And we typically find Fiber Channel, SCSI, or iSCSI attachment technologies typically used by Security Center servers. Typical storage architecture for a Genetec archiver role. Genetec archivers are often configured to save video recordings on a SAN or a storage area network. Gigabit Ethernet can be used to carry iSCSI commands for the data transfers of up to 1 gigabit per second. The more storage available and faster the throughput, the better the system's performance. This concludes Module 1. Thank you.